Hey, okay, so lesson 8 in Unit 1, the very last one in Unit 1 is about the intermediate value theorem, and you can always abbreviate that as IVT. All right, so this can always be abbreviated as IVT, and everyone knows what you're talking about. All right, now, and it's kind of cool because like we're gonna see some problems that are very similar to what you'll see on the AP exam. But this thing starts off talking about if then, and you may have had a bit of that in geometry way back in the day. Uh, the if part is the hypothesis, and the then is the conclusion. So as long as the hypothesis is met, then if the if then statement is true, the conclusion must be followed up upon. So in this lesson, this is our first existence theorem, which is saying qualifications for certain things to be true. And on this particular ones, the intermediate value theorem says the continuous function cannot skip values. I mean, that's pretty much it. If you're heading from a y value to another y value, then and it's continuous, you're going to draw it without picking up your pencil, then it'll hit every single value in between those two at least one time. I mean, it could do like a sine curve and hit a whole bunch, but it's at least going to hit one time. We know that's true because how would we travel otherwise? All right. So using an if then statement says if the function y equals f of x is continuous from a to b, okay, including a to b, notice the brackets there, then f of x takes on every value between f of a and f of b. So all of the y values. It'll take on all the y values in between. All right. Another approach said in a different fashion, if we know that a y value says y equals k resides between two endpoints of f of a and f of b, then we're guaranteed at least one x value where y x equals c between the points where that f of c is equal to k. It's the same thing. It's just saying there's some c in between that gives us this k y value that's in between f of a and f of b. Let me show you what I'm talking about here. So say we're traveling. Say right here is the point a f of a. All right, and then over here is the point b f of b. Very nice. And then whatever it does, I mean, I don't know. And let's see if we can change that up a little bit. Oh, it's down here. Okay. So let's say, all right. So let's say in between, we have some value C that's in between f of A. There's f of A and there's f of B. So here's f of A. That looks really good. And then f of B. Yay. And C is in between. Sorry, f of C is in between. And therefore, there's at least one time where that's going to happen. Now, it could happen multiple times. So I don't want to label down here really because it could go right and then travel there, or it could just go straight there like a line or whatever. But what we're saying is if I'm going to travel from AF of A up here, that I know at least one time we're going to have a C value where f of c is going to equal the value we were talking about in between. Now, again, it could do something like this, as you know. It could go wee and hit a whole bunch of times, but what the existence theorem is saying is going to hit at least one time. So in this case, it would have been 1, 2, 3, 4, 5 times. Okay. Now you can use the exact same thing in dealing with zeros. Okay, so say f of a or f of b, it doesn't matter. If one of them is below the x-axis, in other words, less than 0, then and the other one is greater than 0, makes no difference which one, could happen in either direction. Then we know that in between there's going to be a 0. Okay, so let's say in this instance, f of a is down here, and then f of b is up here. Okay, so this time it's just saying, and this time our f of c, the particular value we're wanting, is a 0. And so if I'm traveling from here, and let's say this one's positive, right there, and if I'm going, then we know that it's going to hit the x-axis, or it'll give you a 0 at least one time. Whee! Like that. So there's at least one. And again, it could do like a sine or whatever, they could do whatever. But again, we're just looking to see if it happens one time. Okay, at least one time. All right, that's example 1.